Today, today we're going to be going over motion graphs. So graphing motion can help you solve problems. So motion graphs describe the motion of an object. Is occasionally hard to do with words. So describing motion graphically is sometimes easier than using words. Sometimes graphs can help make motion easier to picture and therefore understand. So motion is a change in position measured by distance and time. Speed tells us the rate at which an object moves. Velocity tells the speed and direction of a moving object. And acceleration tells us the rate, speed, or direction changes. So we're going to have multiple different types of graphs. The first one is distance time graph. So it's plotting distance against time. It can tell you a lot about motion. Time is always plotted on the x-axis at the bottom of the graph. The further to the right on the axis, the longer the time from the start is gone by. Distance is always plotted on the y-axis, the side of the graph. The higher up on the graph, the further from the start. If an object is not moving, it'll stay at the same distance away from the start. So time is increasing to the right, but the distance does not change. It is not moving, and we say that when an object's not moving, we say that it is at rest. So if an object is moving at a constant speed, it means it has the same increase in distance in a given amount of time. So if we look at a time unit that is this long, we can see that it increased this much. Or if we look over here, we can see the same amount of time increase that much. So time is increasing to the right and the distance is increasing at a constant rate. The object moves at a constant speed. So constant speed is shown by a straight line on the graph. If we were to look at two objects moving, both of the lines in the graph show that each object moves the same distance, but the steeper dashed line got there before the other one. So if we're seeing who can reach this distance first, this one got there in less time than this one. A steeper line indicates a larger distance moved in a given time. In other words, higher speed. So this one's the steeper it is, the faster the object's moving at. Both lines are straight, so both are moving at constant speed. Graphs that show acceleration look differently than those that show constant speed. The line on this graph is curving upward. This shows an increase in speed since the line is getting steeper. In other words, at a given time, the distance the object moves is getting larger, is thus accelerating. So if you're getting faster and faster, your speed is the line is getting steeper and steeper. And the more steep you are, the faster you're moving. Does that make sense? So in summary, a distant time graph tells you how far an object has moved with time. The steeper the graph, the faster the motion. A horizontal line means that the object is not changing its position, it's not moving, it's at rest. A downward sloping line means the object is returning to the start. So here, this is telling you fast speed. Here, you have a steady speed, you're still moving forward. But here, you're so far away. So if you were to walk So if you were to walk maybe 10 feet forward, so you're starting here, you move 10 feet, you're moving at constant speed, and then you stay at 10 feet. You're stationary, you're still 10 feet away from where you start. You turn around and come back, and you reach 0 feet. So 0 feet, like down here. So you start at 0 feet, you move 10 feet up, stop, and then come back. Acceleration looks like a curve. It's getting steeper and steeper. It means that you maybe started out walking, then jogging, and then starting running. So which of these graphs shows one of the runners started at 10 yards further ahead of the other? So which of these graphs show that at the very start, one runner was 10 yards further ahead than the other? So we look at the start. So this is the start. We see one's at 0 and one's at 10 yards. So the difference between them is 10 yards. Here, they're at the same spot. They're both 10 yards away from the start. Here, they're 20 yards apart. Here, again, they're both at the 0 yard marker. So one is at one is at 0 yards. The other is at 10 yards. So there is 10 minus 0 yards away. So 10 yards away or apart. So A is the correct answer. And that should be. So they are 10 minus 0. Everyone good? So, in which of the following graphs do both runners move at the same speed? The answer is D. So, in which of the following graphs are both runners moving at the same speed? So, let's show you how to calculate speed. So here we can see that this lasted 4 seconds. Here, 30 yards. So at the very beginning, he went from 20 yards to 30 yards. So he traveled a total distance of 10 yards. So he did. So speed equal to distance over time. So he traveled a total distance of 10 yards. He did this in 4 seconds. And so that's 2.5 yards per second. This person also went from 10 yards to 20 yards. So that's 10 yards right there. And he did that in 4 seconds. So both of these lines are parallel. Remember, the steepness of the line tells you how fast they're going. If they're both going at the same rate, it would have both the same steepness. Make sense? Alan, keep your head up. By the way, the code word of the day was beta. That's for remote learners. Alright, so the distance time graphs below represent the motion of a car. Match the descriptions with the graphs. Explain your answers. So, graph A matches which description? So A matches which one of these? So the car is traveling at a constant speed. So this will correspond to 2. We know this because it's a straight line. Graph B corresponds to which one?
Excuse me, teacher, this for another interruption. There will be no after-school practices today after all. Earlier, I told you there would be, but there is canceled for today and the remainder of this week through the weekend. There will be no after-school practices. If you need to call and make arrangements for being picked up at 3:30 today, you may do so. Be ready.
So B, which one is B corresponding to? It would be 4. You're coming back to the start. So this would be 4. We know this because it's a because it has a negative slope. Negatively sloped line. C, which one does C correspond to? So C corresponds to 1. You are stopped. Your distance is staying put. You're not moving. You're at the same distance. You know this because it's a flat line. Distance isn't changing. That should say. Which one does D correspond to? So the speed of the car is decreasing. So here you can see it's pretty steep. It's getting less steep, and it's slowing down to where it's not even moving. It's also curved. So acceleration, acceleration is change in speed, and if your speed is changing, it's going to be a curved line. So on that note, if you are speeding up, or should I, if you're slowing down, Slowing down lines look like this. Speeding up looks like this. Everyone good? So now let's look at speed time graphs. Speed time graphs look much like distance time graph. Make sure you read the labels. This says speed. They're also called velocity time graph. So make sure you're reading the actual label. Time is always plotted on the x-axis. Speed or velocity is plotted on the y-axis. A straight line, a straight horizontal line, means that the speed is constant. So if the line is straight, it means that your speed isn't changing. It's constant. A straight line does not mean the object is not moving. So if the line is straight, it means you're moving at a constant speed, wherever this value would be. This graph shows increasing speed. The object is accelerating, it's getting faster. So here your speed is increasing, so you're going from like 0 miles per hour to like 60 miles per hour. Your speed is increasing. Here, your speed would be decreasing. It's also known as deceleration. When we compare two objects, so we can see that both of these lines are mean that they're both speeding up, but the dashed line is speeding up faster, so it has greater acceleration. So both of the lines reach the same top speed, wherever this top speed was. So this is will be their top speed. And they both, but this one does it in this amount of time, and this one took longer. So a speed time graph shows us how the speed of a moving object changes with time. The steeper the graph, the greater the acceleration. A horizontal line means the object is moving at a constant speed. A downward sloping line means that they're slowing down. So here they have steady acceleration, so you can imagine that you're starting at 0 miles per hour. Then you go up 10, 20, 30, 40 miles per hour. And then you stay steady at 40 miles an hour right here. Here you go to pass someone, for example, and you increase your speed to 50 miles per hour. And then after you pass them, you realize you missed your turn, and you slam on the brakes, and you slow back down to 0 miles per hour. So the speed time graphs below represent the motion of a car. Match the descriptions with the graph and explain your answer. So graph E matches which description? The car is accelerating. We know this because it's a positively sloped line. Which one does F match? So 8. We know this because it's a negatively sloped line. The speed is decreasing. Which one does G represent? No, it has a speed. This would be 6. It's because it's a flat horizontal speed. A horizontal line. And the last one is the car is stopped. We know that it is stopped because the speed is 0. Alright. So look at the graph above. It shows how 3 runners ran a 100-meter race. Who won the race? So Albert won the race. How do we know he won the race? He traveled 100 meters in 12 seconds. He ran 100 meters in 12 seconds, which is faster than the others. Also, make sure that when you're looking at graphs, you make sure that this is a distance, not a speed. So, which runner stopped the rest? So, Charlie stopped right here and rested. His distance isn't changing during that period. So, Charlie stopped because we see a flat line. How long did he stop for? So he stopped at 8 seconds, and he goes to 13 seconds. 13 minus 8 is 5 seconds. So he stopped between 8 seconds and 13 seconds. How long did it take Bob to complete the race? So 14 seconds. He stopped at 14. It's the point in which he reached. So we know this because it is the point in which he reached 100 meters. So he reached 100 meters at the 14-second mark. Calculate Albert's average speed. So remember, average speed is equal to total distance divided by total time. So looking at Albert, he went a total distance of 100, and he did it in 12 seconds. So his total distance is 100 meters, and he did it in 12 seconds. So his speed is 8.333 meters per second. Make sense? So the graph below shows the speed of a bus as it changes on its journey. So this is going to be a speed time graph. So these values represent speed. So the bus, so between 0 and A, this bus is doing what? Accelerating. So between this segment, it's accelerating. Between A and B, the bus is doing what? That'd be constant speed. It's still moving, but it's with constant speed. The speed is 10 meters per second. And what is he doing during this segment from B to C? It would be decelerating. He's slowing down. What about from C to D? Resting. So the speed was 0. So it's at rest. And what about between D and E? So that'd be accelerating. Pretty easy, right? Yeah, technically, this was supposed to be, I was going to do this tomorrow and have y'all do it in class. But y'all are not going to be here tomorrow. However, we're still having school tomorrow. Everyone's becoming a remote learner for tomorrow. I will release a video tonight for tomorrow's lesson. But I want this homework back first thing Monday. I think my plan is going to be we come back Monday, I give a review, and we'll have a test Tuesday. That's it for today.